There is what I refer to as major function and minor function. Major function is what identifies that function for you. For example, if I call this function a polynomial function, power rule related function, power rule term, what makes this a polynomial or a power term is this n. True or false?
True.
Good. So I will call it a major function. I'll call it a major function. Then this, I will call it a minor function. I'll call this the minor function. I'll call this the minor function. So differentiation is all about differentiate the minor, differentiate the major, multiply both of them. I repeat, differentiate the major, differentiate the minor, multiply both of them. You can differentiate anyone first, it doesn't matter. Since it is multiplication that combines them. Are you getting me right?
Yes.
I know in multiplication, if I give you 2 times 8, it's the same as 8 times 2. True or false?
True.
So you can do any one of them first. Either you differentiate the minor first, before differentiating the major, or you differentiate the major first, before differentiating the minor. Apart from this function, it's only polynomial function that I like differentiating the major first, before the minor. For the rest of the function we're going to meet, we'll differentiate the minor first, before the major. It's not a law anyway. It's not a law. The reason is because of the way the answers are being presented. Apart from this one, for the other functions, the differentiation of the minor part is usually presented first before the part that contains the derivative of the major. So apart from this function, please, apart from polynomial, the rest, I will differentiate the minor first before the major. All right, dear friend, do you understand this?
Yes, sir.
I know that for now you'll be wondering, what is this one? This particular part, don't bother. It's only when we pick question that this will make more sense. This is the main thing there. This is the main thing. When the function is in its simplest form, like this one, y equal to 2x raised to power 5, something like this. When it is in this simplest form, you don't need to do this part. The reason is because the minor is simply x here. The minor is simply x. If you're reading your ABCD, when you get to x, how do you pronounce x?
X.
Good. So that function of x is simply that x. Whenever the minor function is in its basic form, like the way you meet it in your alphabet, in your letters, you don't need to do the derivative of the minor. You don't need it. The reason is because it will always give you 1. And 1 times anything is that thing. So for functions like this, just do derivative of the major and your problem is solved, which in this case is this part. Use the power, multiply the base, go to the power and subtract 1. For example, like this guy particularly now, with this you can quickly tell the answer, nothing is there. Your dy dx here will be equal to, can we do that? Our n is 5 here, so you use the 5 to multiply the base. What will you get? 5 times this 2 will give you what?
10x.
10x. Go to the power and subtract 1. So what will you get as the new power?
4.
Is this a difficult math?
No.
That's it. And it's a simple math, like I said. It's a simple math. Now, in this case, if I were to differentiate the minor function here is x only. X only, you see? That's the function of x. If I give you x alone and you differentiate, since it is x alone, you will get 1. Do you believe it?
Yes, sir.
Good. The power here is 1. Use 1 to multiply the base. 1 times 1x will give you 1x there. Go to the power, subtract 1. 1 minus 1 is 0. X raised to power 0 is 1. 1 times that 1 multiply will still give you 1. So if I differentiate the minor function here, which is this part, this is meant to be times 1. True or false?
True.
Which still maintains the major differentiation you did earlier. So for functions like this, but look at this one. If I give you y to be equal to x raised to power 3 plus, let's say 2, and then let's say raised to power 4. Can you identify your f of x for me here?
Can I find it?
Can you identify? Tell me what is your f of x here and what is your n? Okay, what is your n here first? What is your n? Because this is a polynomial function. You can see a variable as base, alphabet part as base, and then a power, you know. So what is your n here in this function?
4.
You are very correct. Therefore, hence, what is your f of x?
X cubed plus 2.
Put your hands together for yourself.
Thank you.
That's good. Now, let us move on. In this case, what you have to do, your dy dx will be equal to, you differentiate from the major, use the power, multiply the base, go to the power and subtract 1. Tell me the value of that part.
4. Open bracket. X raised power 2 plus 2. Close bracket 3.
With this, have you gotten your answer?
No, sir.
No. You've only done this part. Are you following, right?
Yeah.
If you are reading your ABCD and you get to X, once again, how do you read X?
X.
Good. Do you read it as x raised to the power 3, x exponent 3 plus 2? Is that the way you read it?
No.
No. So the f of x, the minor function in this case, is no longer in its basic form. It's no longer in its basic form. That is why you must do the derivative of the minor. This is the part that terrorizes students. It is because of that thing that will bring in what is called chain rule, where before you know what happens, you'll be told, let u be equal to this. And I put it to you, that is one of your... You didn't like that part so much when... Am I correct? No, from there you start seeing some technicalities in differentiation. But don't worry, with what we are doing here, all of this will be broken down 1 plus 1. Anytime the function, the minor function, is no longer in its basic form, you must remember that you need to differentiate the minor function. So I will come to this bracket and differentiate. X raised to the power 3. If you differentiate x raised to the power 3, what will you get? Remember, it's also a polynomial function. Use the power, multiply the base, go to the power and subtract 1. Is that not so?
Okay.
So this is going to be times... If you do that here, for this x cubed, what will you get?
3x raised to the power 2.
Then plus... This is a pure number without wasting time. If you differentiate a pure number, you get 0. Remember, we are differentiating with respect to x, dy dx. Dy dx. This 2, is it multiplied by any x?
No, sir.
No. So if you differentiate it, it's a pure constant. The answer will be 0. So this is meant to be 3x squared plus 0. Forget about the 0. This is the result of this differentiation. All you just needed to do now is multiply this 4 by 3. You get 12 x squared, then bracket x raised to the power 3 plus 2, all raised to the power 3. This is the answer. Remember, we are not solving questions yet. I'm trying to expose how simple differentiation, calculus, really is. Especially for you dear friends at this basic level coming up. Yeah, that's at this O level, senior class as you are. You don't need to be scared of this. Whenever I hear people say that calculus is difficult, they are telling lies. They are saying it because even they themselves don't even understand it. It's just like someone who has not been to Lagos before, like me. I've not been to Lagos. And then I come telling you things about Lagos. Does it make sense? No. So please, I want you to know today that calculus, see, I can't deceive you. I'm telling you the truth the way it is. Calculus is simpler. Further maths is simpler than the maths that most of you think. You understand that it's not difficult, which is general maths. Further maths is simpler than that general maths. Okay, so I have explained how you apply this formula. Let us move on to the next standard, number 2. This time around, we'll be looking at trigonometric function, trig functions.